Here we have a calculus problem. That is, we have to find the maximum and minimum values of the curve represented by the equation y equals to 4 times x to the third power negative 6x to the 6 times x to the second power positive 3. Okay, first let me tell you how to do the problem over here. So my first work is to find the first derivative and second derivative of the given equation. So once I get the first derivative and second derivative, I have to get the critical points or critical numbers. So the second step. In the third step, I have to plug in the critical numbers into the second derivative and find the maximum and minimum values. Okay, now first let me find the first derivative. So for that, let me write the given equation as it is. It is y equals to 4x cubed negative 6x squared positive 3. So I just find the first derivative. When I find the first derivative, it will become y prime. And here 4 times the derivative of x cube is 3x squared. Negative, I keep this constant 6 as it is, and when I find the derivative of this x square, it just become 2x, and the derivative of this constant 3 is 0. So then y prime equals to 4 times 3 is 12x square, negative 12x. And now I'm going to find the second derivative. So when I find the second derivative of this y prime, it will become y double prime. So now, so here constant is multiplied by the variable. So when I find derivative of some stuff, if there is a constant multiplied by the variable, I have to keep the constant as it is, and I have to find the derivative of this variable part. When I find the derivative of this x square, it will become 2x negative. So again, a constant is multiplied by the variable. Let's keep the constant 12 as it is. When I find the derivative of this variable x with respect to x, it will just become 1. So then y double prime is equal to 12 times 2 is 24x negative 12. Okay, now I got the first derivative and second derivative. My next step is I have to find the critical points. So I can find the critical points by equating the first derivative to 0. Okay, let me equate the first derivative to 0. Then I'm getting 12x squared negative 12x equals to 0. So the greatest common divisor for these two terms is 12x. So I can factor 12x out. So when I factor 12x out, I'm getting x negative 1 inside the parenthesis. So even if I distribute this 12x to this x and negative 1, I'm getting this stuff. Okay, now the multiplication of these two terms equals to 0. So whenever the multiplication of two or more terms are equal to 0, then either the first one is 0 or the second one is 0. So let me equate the first term to 0, and also let me equate the second one to 0. So now to solve for x, I divide both sides by 12. Then this 12 will cancel out. I'm getting x equals to 0, 12 is 0. Now to solve for x, I'm adding 1 to both sides. Is negative and positive 1 will cancel. I'm getting x equals to 1. Okay, so when I equate the first derivative to 0, I'm getting two values for x, 0 and 1. So these two values are called critical numbers. And apart from this, we have to check whether there is any value of x for which the first derivative does not exist. There is this y prime becomes undefined. Actually, we don't have rational expression over here. If there is any rational expression, then there is a chance that the first derivative becomes undefined for some value of x. But here there is no value of x for which this y prime becomes undefined. In case if there is any value of x for which y prime becomes undefined, that value of x also should be considered as critical numbers. Okay, here there is no such a value for x for which y prime becomes undefined. So there are only two critical numbers. So 0 and 1, let me write over here. So critical numbers or critical points equals to 0, 1. Okay, now what I need to do is I have to plug in these critical numbers into the second derivative over here. Let me plug in. So when x is equal to 0, then y double prime equals to 24 times 0 negative 12, which is 24 times 0 is 0, 0 negative 12 is negative 12, so which is less than 0. So when x is equal to 0, y prime becomes negative. So whenever for some value of x, I mean for a particular critical number, if the second derivative becomes negative, then we have to decide at this value of x, the given function as a maximum value. Okay, so at x is equal to 0, 1 second, let me write over here. At x equals to 0, there is a maximum. There is a maximum value. Okay, to get the maximum value, what I need to do is I have to plug in this critical number 0 for x into the original equation. So the maximum value equals to 4 times 0 negative 6 times 0, because when I plug in 0 here, 0 to the third power is 0, 0 to the second power is also 0, positive 3. So finally this is 0, 0, positive 3. So the maximum value of the curve represented by the equation is 3. Okay, now what we can do is we can plug in the second critical number into the second derivative. That is when x is equal to 1, Let's plug in this number 1 for x into the second derivative over here. Then I'm getting 24 times 1, negative 12, which is 24, negative 12, which is 12, and here greater than 0. So when you plug in x equals to 1, the second derivative, that is y double prime, becomes positive. So whenever for some critical number, if the second derivative becomes positive, then we have minimum value at that critical number. That is at x equals to 1, there is a minimum value. Let me write over here. There is a minimum value. So to find that minimum value, what I need to do is, so I have to plug in that the 1 for x into the equation, given equation. Then I'm getting 4 times 1 cube, negative 6 times 1 square, positive 3. So 4 times 1 is 4, 6 times 1 is 6. So 4 negative 6 is negative 2, negative 2 positive 3 will become just positive 1. So for the given curve, the maximum value is 3 and the minimum value is 1.